Okay, guys, so I'm going back. This is section 6.1, video 2, number 2. Okay. So we stop in video 1. The last thing what I went over, it was the example from page 409, example 29, when they gave us two functions and they asked to find the composite function in its domain. So I did with you guys A and C. I'm just going to do one more, B. So you need to create G composed with F and find its domain. So let me go back. They gave you function f of x, it's equal 3 divided by x minus 1. And the g of x is equal to over x. So first what we're going to do, we're going to create a composite function, g composed with f of x, which is the same as g of f of x. Now function g, it's outside right now. Okay, so function g, it's outside. So I'm going to copy the equation of function g. So we're having 2 over x. Okay. However, where we used to have x, we're going to plug in function f. So function f replacing x of function g. Function f has equation as 3 over x minus 1. So we plug in that 3 over x minus 1. Okay, so this is g composed with f. We start with equation of function g, which originally was 2 over x. Instead of x, I put the backs, and I'm showing you the substitution. Equation of function f, replace the x. Now here you will need to simplify. Okay, so you technically have fraction divided by fraction, because 2, it's the same as 2 over 1, or 4 over 2. So I'm going to apply that keep change flip. I'm going to keep 2. I'm going to change division to multiplication, and I'm going to flip over the bottom fraction. So that will become x minus 1 over 3. And now what you have number multiplied by fraction. That means you only multiply numerator by 2. So we will end up with 2x minus 2 over 3. So this is our composite function. This is function g composed with f of x, which has equation 2x minus 2 divided by 3. Now, when we have the composite function, we need to find its domain. So first, find domain of inside function. So our inside function is function f. Okay, that's inside. So f of x has the equation as 3 divided by x minus 1. And you need to find the domain of inside function. You see a fraction, which means rational function, take the denominator and make sure that it's never equal to 0. Solve for x, we're getting x can be equal 1. What that means, domain of f which is again inside function, is all real numbers except x equal 1. So this is what we have. Now, second, of course, you need to find the domain of your new function, which we just composed. So we have to find the domain of the composition of the composite function, g composed with f of x, which is 2x minus 2 divided by 3. Okay, so look. Okay, so look what happened. Okay, this function actually, it's linear function, because to see that better, you guys actually can simplify that, and this function is the same as 2 over 3 of x minus 2 over 3. So it's a linear function. So this is not rational, this is linear function. So for linear function, domain is always all real. Okay, linear function slope it's 2 over 3, y-intercept it's negative 2 over 3. So the last part, combine both domains. Since from the second part, our function which we just create, its domain it's all real. However, domain of inside function was all real numbers except 1. So our final solution will be all real numbers except 1. So domain it's all real numbers except 1. So I'm going to use the interval notation. For domain of our function, we can pick any x we wanted except 1, which means it's going to be interval from negative infinity to 1, union 1 to positive infinity. Okay, so that was a composite function and its domain. And the last part of section 6.1, let me just double check, make sure I'm not skipping anything. Okay, last one, it's going to be showing different problems. Okay, so example. Here we're going to showing that two composite functions are equal. Okay, and for this example, I'm going to use your textbook. This is from page 409. Exercise 39. So you need to show that f composed with g of x is the same as g composed with f of x, and that will give you x. Okay, so in our problem, function f has equation 2x and the g of x has equation 1/2 x. In next section 6.2, it's going to be the definition that if f composed with g and g composed of f, they both equal and all the time gives you x, those functions are inverses of each other. But we're going to talk about it next week. So how are we going to do it? Okay, so technically you have to show. So first, show that f composed with g of x will give you x. So how are we going to show that? We just have to create that composition. Okay, so f composed with g is the same as f of g of x. F it's outside, so I copy outside function, which is 2 times x, and I replacing x with equation of function g. Function g, it's 1/2 x. So I'm plugging in 1/2 x. And I'm going to multiply. So we're getting 2 times 1/2 x, and that will give us x. So far we're good. I'm going to put the check mark. F composed with g of x, it's definitely equal to x. So we show that. Second, show that g composed with f of x, it also equal x. So let's create that composition. G composed with f of x is the same as g of x of x. Okay, outside function it's g, so I copy 1/2. Originally we have x, however that x is going to be replaced with equation of function f, which is 2 times x. So simplify, and we're getting 1/2 times 2x, which is x. That's it. We just show. There is nothing else what we can do. So that's true. What that means that those two functions, 2x and 1/2 x, they are inverses of each other. Next one. Finding the components of composite functions. So that's the last one. The last equations, the last examples in section 6.1, it's going to be about finding the components of composite function. Okay. So I really like those type of problems. Okay, so let me just explain it to you guys. Example. F composed with G. Okay. So our two function, which is the same as f of g of x. Okay, we call f and g components. And they will give you, when you doing the composition, they will give you brand new function. Okay, so that's which we call composite function. So what happened here, they're going to give you composite function, and you have to decide what is the equation of function f and what is the equation of function g. So what are the components? How we build that composition. So they give you the final piece, and you have to figure out how we create that function. Okay, so again, the best way to explain that, it's doing some problems. So this is page 409. And we'll start with exercise 47. You have to find functions f and g. So that f composed with g, it's equal x. H. So you have to find the original two function which gave you that composition. So they give you h of x, which is 2x plus 3 to the 4 power. So they gave you, again, this is the composition. So now, that composite function, again, was created by using function f and g. Okay, so now we need to find original functions and f and g. We need to find f of x, which is outside function, and g of x, which is inside function. Okay, so f composed with g of x is the same as f of g of x. and our composition has equation of 2x plus 3 to the 4th power. Okay, so how are you going to do it? I'm suggesting that you will start actually with finding the equation of inside function. So first, find the inside function. That will be easier that way. Find the inside function. Inside function, it's going to be what you see inside, which means expression in the parenthesis, expression under square root, expression inside the absolute value. So inside function, the g of x it's going to be, in this case, what I see inside, it's the parenthesis. And in parentheses, I see 2x plus 3. So this is my inside function. Outside function, second, find the outside function, which will be f of x. So outside function is whatever was inside, which is x to the power of 4, because don't forget how the composition works. You use a g, and g, equation of g replaced with x. So just technically erase what you have inside of the parenthesis and put x. That's going to be your f of x function, x to the power of 4. Okay? So again, that's 2x plus 3. That's it. That's what you guys need to do with those examples. So let's practice a little more, 2 more examples, and we're done. So the same idea. I'm using the example from the textbook. This is page 409, number 49. They give you the composition h of x, which is equal square root of x squared plus 1. And they ask you to find the components, which means find f of x and the g of x. Okay, so we need to find those two equations. So again, don't forget that h is a composition of f and g. So f composed with g, which is the same as f of g of x, will give you that h, which is x squared plus 1. Okay? Okay, so the same idea. Start with inside function, g of x. So g of x, it's always what you see inside. Okay, so in this case, inside the square root, I see x squared plus 1. So that's going to be my inside function, x squared plus 1. And then, so that's the inside function. And then, when I have g of x, I'm finding f of x, which is outside function. So outside, I see the square root. And of course, you have to put your variable, square root of x. Okay, so your f will be, again, if you will erase expression of inside equation, you just have a square root. You have to put x over there. Okay. Okay, so we do. This is outside. So we did it. This is outside function. Usually students are very good with those problems. Sometimes some functions may have coupled solutions. So there's not only one way to find inside and outside function. Okay. Last one. Page 409, number 51. The same idea. H of x, it's equal absolute value of 2x plus 1. You need to find f and g. So you need to find the equation of f of x and g of x. Don't forget that h of x, that's the composite function. Which was created from two functions, f composed with g. Okay, so again, I'm going to start with g of x because it's just easier for me. G of x, the inside. So g of x is what I see inside. So inside I see 2x plus 1. And f of x, outside function, is what you see outside. So outside I see the absolute value. And of course you need to put your variable. Okay, so of absolute value of x. That's the outside. And that's it from section 6.1. So this week, after the test, you should study 5.4. I think you have 4 videos. And section 6.1, which has only 2 videos. And then next week, I will upload more videos. So good luck with the test, and which is today. And I will talk to you guys next week. Bye.